Good day everyone! Welcome back to General Mathematics. It is still me, Engineer Umengan, to teach you logarithmic functions. Welcome to Logarithmic Functions, LBV Math 1-5.3b. In this topic, our most essential learning competency solves logarithmic equations and inequalities. The topics covered in this video are laws of logarithms, problems involving logarithmic equation, and inequality. For our learning objectives, by the end of this video, we want to know the different laws of logarithms used in solving logarithmic equations and inequality, to solve problems involving logarithmic equations and inequality. Now let's try something harder. Problem number 14. If log of 2 equals 0.3010, log of 3 equals 0.4771, log of 5 equals 0.6990, and log of 7 equals 0.8451, evaluate log of 26.25. 26.25 in fraction form can be expressed as 105/4. Therefore, giving us log of 26.25 equals log of 105/4. From our property of logarithm, if we have a logarithm of a fraction, that is equal to the logarithm of the numerator minus the logarithm of the denominator. Or in other words, if we have log of x over y to the base b, that is equal to log of x to the base b minus log of y to the base b, giving us log of 105/4 equals log of 105 minus log of 4. But we can express 105 as the product of 3, 5, and 7, and 4 equals 2 squared or 2 times 2. Now that we have this, we can now proceed to our next property of logarithm. If we have a logarithm of the product xy to the base b, that is equal to the log of x to the base b plus log of y to the base b, giving us log of 105 equals log of 3 plus log of 5 plus log of 7. And if we have the logarithm of x raised to n to the base b, that is equal to n log of x to the base b, giving us log of 2 squared equals 2 log of 2. From there, log of 105 is equal to log of 3 plus log of 5 plus log of 7. Again, log of 105 can be expressed as log of 3 plus log of 5 plus log of 7, and log of 4 or log of 2 squared equals 2 log of 2. But since we have here a division, therefore, our operation will be minus. Using the values from the given, log of 3 is 0.4771, log of 5 is 0.6990, log of 7 is 0.8451, and log of 2 is 0.3010. Performing this, that is equal to 1.4192. Problem number 15. If log of 2 equals 0.3010, log of 3 equals 0.4771, and log of 5 equals 0.6990, evaluate log of 14.4. 14.4 in fraction form is equal to 72.5, giving us log of 14.4 equals log of 72/5. From the property of logarithm log of x over y to the base b, that is equal to log of x to the base b minus log of y to the base b. We will have log of 72/5 is equal to log of 72 minus log of 5. But we know that 72 is equal to 8 times 9, but we need to express it as a product of combination 2, 3, and 5. We can express 8 as 2 cubed and 9 as 3 squared. Therefore, giving us log of 2 cubed times 3 squared minus log of 5. From there, using the property logarithm of the product, or the log of xy to the base b, equals log of x to the base b plus log of y to the base b. We can express log of 2 cubed times 3 squared as log of 72 equals log of 2 cubed plus log of 3 squared. Next, we will use this property of logarithm. Log of x raised to n to the base b is equal to n times the log of b, or log of x to the base b. So, log of 2 cubed can also be expressed as 3 log of 2, and log of 3 squared can be expressed as 2 log of 3. Now, we will have 3 log of 2 plus 2 log of 3 minus log of 5. But we know that log of 2 equals 0.3010, log of 3 is equal to 0.4771, and log of 5 equals 0.6990. We will substitute this value to our equation, giving us 3 times 0.3010 plus 2 times 0.4771 minus 0.6990. That will give us 1.1582. Problem number 16. Evaluate log of x squared plus 1 to the base 4 minus log of x minus 4 to the base 4 given that x is equal to 7. In our problem, we have subtraction of logarithms with the same base, so we will be using the property log of x to the base b minus log of y to the base b is equal to log of x over y to the base b. So if we have log of x squared plus 1 to the base 4 minus log of x minus 4 with base 4, that is equal to log of x squared plus 1 all over x minus 4 to the base 4. Substituting x equals 7 to this expression, we will have log of 7 squared plus 1 over 7 minus 4 to the base 4, and that is equal to log of 50 over 3 to the base 4. Typing this to our calculators, that is equal to approximately 2.03. Problem number 17. By applying the properties of natural logarithms, we can see that the equation 3 ln of a plus 2 ln of 1 is also equal to blank. We know that ln of x is equal to the log of x to the base e, giving us ln of e is equal to log of e to the base e. But we know that if we have log of b to the base b, that is equal to 1. Therefore, if we have log of e to the base e, that is equal to 1. Now, taking ln of 1, we already know that ln of x equals log of x to the base e. Therefore, if we have ln of 1, that is equal to log of 1 to the base e. But log of 1 to any base b is equal to 0. Therefore, log of 1 to the base e is equal to 0. Substituting these values to this equation, we will have 3 times 1 plus 2 times 0. And that is equal to 3. Problem number 18. Find the solution set of log of x plus 1 to the base 4 is less than log of 2x to the base 4. In this problem, let me introduce to you the property of equality for logarithmic equations. If we have log of x to the base b, that is equal to log of y to the same base b, then we can say that x is equal to y. We should take note that both logarithms should be expressed with the same base. like in our problem. Therefore, applying this property to our equation or inequality, that will give us x plus 1 is less than 2x. We can observe that both logarithms are expressed with base 4. Subtracting x from both sides, we will have x plus 1 minus x is less than 2x minus x. So x minus x is 0, leaving us 1, and 2x minus x is x. Therefore, we will have 1 is less than x. Or in other words, it can be x is greater than 1 or from 1 to positive infinity. Problem number 19. Find the solution set of log of 3x plus 5 to the base 2 is greater than or equal to log of x minus 9 to the base 2. Using the property of equality for logarithmic equations, that is, if we have log of x to the base b is equal to log of y to the base b, then we can say that x is equal to y. Thus, giving us 3x plus 5 is greater than or equal to x minus 9, because we can observe that both logarithms are expressed with base 2. Subtracting x and 5 to both sides, we will have 3x plus 5 minus x minus 5 is greater than or equal to x minus 9 minus x minus 5. 3x minus x, that will be 2x, and 5 minus 5 is equal to 0, leaving us 2x, and x minus x is equal to 0, and we have negative 9 minus 5 is equal to negative 14, leaving us with 2x is greater than or equal to negative 14. Dividing both sides by 2, we will have x is greater than or equal to negative 7. Or, in other words, from negative 7 to positive infinity. Problem number 20. Find the solution set of log of x plus log of x minus 3 is less than or equal to log of 10. Using the property log of xy to the base b is equal to log of x to the base b plus log of y to the base b. That will give us log of x plus log of x minus 3 is equal to the log of product of x and x minus 3. And that is equal to log of x squared minus 3x. Now, we will have log of x squared minus 3x is less than or equal to log of 10. By using the property of equality for logarithmic equation, and that states if log of x to the base b is equal to log of y to the base b, then we can say that x is equal to y. Applying this property, we will have x squared minus 3x is less than or equal to 10. Or transposing 10 to the other side, we will have x squared minus 3x minus 10 is less than or equal to 0. By factoring x squared minus 3x minus 10, we will have x minus 5 times x plus 2. Both are less than or equal to 0. So we will have x minus 5 is less than or equal to 0, and x plus 2 is less than or equal to 0. And that will give us x is less than or equal to 5, and x is less than or equal to negative 2. However, from the original inequality, remember that the argument should be greater than 0. Therefore, for log of x to exist, x should be greater than 0. Therefore, we cannot consider this 1. And for log of x minus 3 to exist, x minus 3 should be greater than 0 or x is greater than 3. Therefore, we can only allow the following values: greater than 3, 4, and should be less than 5. Therefore, from 3 to positive 5. Problem number 21. Find the solution set of log of x plus 4 to the base 3 plus log of x minus 4 to the base 3 equals 2. Using this property, log of xy to the base b is equal to log of x to the base b plus log of y to the base b. Our log of x plus 4 to the base 3 plus log of x minus 4 to the base 3 will be equal to log of x plus 4 times x minus 4 to the base 3. And that is equal to log of x squared minus 16 to the base 3. Therefore, giving us log of x squared minus 16 to the base 3 is equal to 2. Using this, or converting this into our exponential form, we will have x squared minus 16 equals 3 squared. Or x squared minus 16 is equal to 9. From x squared minus 16 is equal to 9, we subtract 9 to both sides and we will have x squared minus 25 is equal to 0. Factoring this, we will have x plus 5 times x minus 5 is equal to 0. Therefore, giving us the following values, x plus 5 is equal to 0 and x minus 5 is equal to 0, or x is equal to 5 and x equals negative 5. However, from the original inequality, remember that the argument should be greater than 0. So using x is equal to 5, if we substitute 5 to x plus 4, that will give us 9, which is greater than 0. And if we substitute it to x minus 4, that is equal to 1, that is still greater than 0. Therefore, we can allow x equals 5. However, if we use x equals negative 5 and substitute it to x plus 4, we will have negative 5 plus 4, and that is equal to negative 1, which is less than 0. And using this value to x minus 4, we will have negative 5 minus 4, and that is negative 9, which is still less than 0. Therefore, it does not satisfy. We will not consider negative 5. Therefore, it will leave us with x equals 5. Problem number 22. Find the solution set of log of x squared minus 1 to the base 5 minus log of x plus 1 to the base 5 equals 3. Applying this property of logarithm, log of x over y to the base b is equal to log of x to the base b minus log of y to the base b. We will express log of x squared minus 1 to the base 5 minus log of x plus 1 to the base 5 as log of x squared minus 1 over x plus 1 to the base 5. However, we can express x squared minus 1 as the product of x plus 1 and x minus 1, giving us log of x plus 1 times x minus 1 all over x plus 1 to the base 5, and we can cancel x plus 1, giving us log of x minus 1 to the base 5. However, from our problem, log of x minus 1 to the base 5 is equal to 3. Expressing this in our exponential form, we will have 5 cubed is equal to x minus 1. And that will give us x is equal to 5 cubed plus 1, and that is equal to 126. Problem number 23. Solve for x in the expression log of negative 2x plus 10 to the base 2 is equal to log of 7 minus 5x to the base 2. Applying the property of equality for logarithmic equations, if we have log of x to the base b equal to log of y to the base b, then we can say that x is equal to y. Therefore, applying this property, we can see that negative 2x plus 10 is equal to 7 minus 5x. So, transposing 5x to the other side, so what we'll do here is Add 5x and subtract 10 to both sides. We have 5x minus 2x that is equal to 3x. And 5x minus 5x is equal to 0 and 7 minus 10 is equal to negative 3. That will give us 3x equals negative 3. Dividing both sides by 3, that will give us x equals negative 1. And that's the end of our lecture. What we learned: the different laws of logarithms used in solving logarithmic equations and inequality, and solved problems involving logarithmic equations and inequality. In our next video, we will learn the representation of logarithmic functions through table of values, graph, and equations. For supplementary problems, you may refer to QuexBook General Mathematics Chapter 3.